Matrix is a rectangular array of numbers, symbols, points, or characters each belong to a specific row and column. A matrix is identified by its order, which is given in the form and rows of the columns. The numbers, symbol, points, or character present inside a matrix are called the elements of a matrix. The location of each element is given by the row column it belongs to. It's a fundamental concept in mathematics and has application in
For
various.
history, the concept of a matrix dates back to ancient times and was named matrix by James Joseph Sylvester in 1850. Matrices were first used between 300 BC and AD 200 in the Chinese texts, 9 chapters of mathematical art, which introduced determinants and solving system of equation with matrices. The Chinese made significant advancements, including the method now known as Gaussian elimination. Gottfried Leibniz developed matrix theory by arranging coefficients of linear equations in a matrix. Carl Gauss expanded this in the late 17th, adding matrix multiplication, inverses, and refining Gaussian elimination. This method involves using elementary row operations to simplify a matrix. Sylvester named the matrix and reinforced its theory by detailing determinants. Arthur Cayley, which is his friend, further contributed by defining matrix operations like multiplication, addition, subtraction, division, and scalar multiplication.
And now I will explain to you the application of the matrix to our real First of all, I will explain to you about the application of the matrix in a computer graphic. Matrices play a crucial role in a computer graphic. They offer a concise and effective method for depicting and controlling geometric transformation. It is crucial for developing and animating objects in a 3D environment. If we explain about the 3D environment, we will remind of animation industry, photography, video renderer, game developer, and so more. Here I show an example of the software that use a matrix concept to design a 3D object. As you can see, it is in the shape of a supercar. And by using this software, we can do more than that shape by make a matrix as a core of the computer graphic.
And
The
G,
second
A,
one
B, C,
is
D, E, F, G
cryptograph.
is the seventh letter
Cryptograph
in our
is the
alphabet.
collection of
So
secure
here's our
information and
numbers, and we're
communication
going to put
technique
these
that
into a
employ
matrix.
a
Now this
mathematical
matrix that
concept
we're going to
and
put them
algorithm that
into
used to
is eventually
disguise
going
the
to be
content of
multiplied
message,
to our
such as a
encoder
hidden message or
matrix.
secret
And
message.
since our encoder
So
matrix is
the
a
methods
2
that
by
are employed in
2,
encrypted
we need to
algorithm,
have
they will work
2
to jumble data
columns
and
in the
render it
matrix that we choose so that we are
incomprehensible
able to
to
do the
unauthorized
matrix
individual.
operation, because remember
For a
the
matrix
inner
that
numbers
apply
have to be the
in
same. So I
cryptograph,
know that I'm going to be
it may
using 2
consist of
columns
random
for my
integers
matrix.
that
So I'm going to
arrange
go ahead
in
and
a
draw
3
this. I
by
don't know how
3
long
matrix,
it's going to be
and
in terms
it
of how
will be
long these
quite
columns are,
straightforward.
but I do know that it's going to be 2
And
columns.
in
And I'm just
order
going to
to
start putting the
encrypt the
numbers
plain
into
text
my
of
matrix
the
in
message,
order. So a
each
1, and then
character
a
in
4,
the plain
and
text,
then the
which is the message,
22, and
must
then the
be denoted
0,
with
and then the
a
1, and the
numerical value,
12, and
and
then
it
the
will
7.
place into a
Now,
matrix
obviously, our matrix is
so
not
that we
yet
can
complete because
generate
there's
what we
something missing
call
here, but since we are
cryptograph.
at the end of our message,
And now I will explain to you about the application of the matrix in economics. Matrices are used in economics to solve problems that is involving linear equation and to model economic data. Many economic models involve multiple interaction variable and equation. Matrices allow to express the system of equation in a compact and organized way. Economists also use matrices to model an economic system and predict future trends. For instance, this input-output model that use matrices to represent the flow of goods and service between different sectors of an economy. As you can see at the video, this is type of the application of the matrix that been used in economic system.
Computer graphics have evolved from automation and cartooning to complex applications like VR, AR, and photorealistic production. Matrices are fundamental in graphic, transforming point in 3D space to 2D projection. Each metric row and column correspond to pixel, with value representing pixel colors. Matrices are used for translation, scaling, and rotation in graphic, and can also represent graph. Modern GPU excel in handling this operation with high parallelism. Advanced techniques like ray tracing and machine learning enhance realism and image analysis. Those computer graphics now offer interactive, realistic experience in virtual art and modeling.